Hello, my name is Professor Adjovan, and this is episode 4 of the Quadratic Series, where we're going to be looking at a third way to multiply polynomials, a skill that you need to know and understand before you can do something like factoring quadratics. This third way I refer to as the stacking method. If you missed the previous two episodes, we talked about in episode 2, foiling, which is the very textbook traditional way to multiply polynomials. And then we talked about a box method, which is very visual. And now we're going to talk about this stacking method, which once you see it might look very similar to how you might multiply two and three-digit numbers back in, elementary school. So we're going to look at three examples in this video. These are the three examples we're going to be doing. So if your homework problems look like this is the right video for you. If you look at these problems and you think you already know how to do these, then I would recommend jumping to episode 5 in this series. But for everybody else, we're going to go ahead and jump into it. So before we even look at polynomials and how to multiply them, I want to recall how we would multiply two-digit numbers like 42 and 16, or a two-digit and a three-digit number like 125 and 37. See how these are stacked? This is why this method is called the stacking method for multiplying polynomials. But let's make sure we understand how to do this first with just numbers, and then we'll throw in some variables and terms and make it new information and more challenging. So if we're doing 42 times 16, the first thing we would do is 6 times 2 gives us, 12. And we would carry the 1, put the 2 down here. 6 times 4 is 24, plus the 1 we carried, 25. And then we go to the tens place, so we put a placeholder 0. 1 times 2 is 2. 1 times 4 is 4. We then add these two together, and we have 2 plus 0 is 2, 5 plus 2 is 7, 2 plus 4 is 6. We get our final answer. If we're doing it with a 2 and 3 digit number, it's very similar, but we just need to go longer. So 7 times 5 is 35, 7 times 2 is 14, plus the 3, 17, carry the 1, put a 7, 7 times 1 is 7, plus 1 is 8. Put our placeholder 0 because we're moving to the tens place. 3 times 5 is 15. 3 times 2 is 6, plus the 1 that we carried over gives us 7. 3 times 1 is 3. And then we can add these together. 5 and 0 makes 5. 7 and 5 make 12. 1, 8, and 7 make 16. 1 and 3 make 4. Okay, so that should have been very reminiscent of something that you've done in the past. But this idea of stacking things on top of each other and multiplying them out in that order, where we take the ones place and we multiply it by the first digit and then the second digit, is what we're going to be doing, but with polynomials. So if this is our problem, if this is what we're given, x plus 3 times 2x minus 5, I can stack these on top of each other. Like I can put x plus 3 and 2x minus 5, and we can multiply them very similar to the way that we just multiplied those normal numbers. So I can take negative 5 times 3, well that's negative 15, and I can take negative 5 times x, and that gives me negative 5x. I like to leave a nice little gap between everything so that I can easily see the difference in my terms. We can put a placeholder 0, and then we go to 2x. So 2x times 3 gives me 6x, and then 2x times x will give me 2x squared. And then just like with the last examples, when we did the regular numbers, we can now add these together. So negative 15 and 0 gives me a negative 15, negative 5x and 6x gives me a positive x, and 2x squared can just come down because it's not being added to anything. And just like that, we have our final answer. We've multiplied it out just like we would do with normal whole numbers. Okay, everything is nice and organized, and because we've kept our terms separated and similar, everything combines nicely into one simplified answer. Let's try it again with something a little bit different. Let's take 3x squared minus 1 and multiply it by 2x minus 5. Let's actually move this -1 over a little bit more. And I can put in a 0x here. I'm going to put this in here as a placeholder just so you can see what's going on. I have my x squared place, my x place, and then my constant place. So below it, I can put 2x minus 5. -5 goes in the constant spot, and 2x is going to go in the x spot. So we can multiply these together. -5 times -1 gives me +5. -5 times 0 will give me 0. -5 times 3x squared is going to give me -15x squared. I can put a placeholder here if I want. 2x times -1 will give me -2x. And 2x times 3x squared is going to give me, sorry, I skipped the 0. 2x times 0x is going to give me nothing. 2x times 3x squared is going to give me 6x cubed. Alright, so the reason why I put this placeholder here is to help keep everything organized and in the right spot, so I don't have an x squared on top of an x cubed. So 5 plus 0 is 5, 0 plus -2x is -2x, -15x squared plus 0 is -15x squared, and then this 6x cubed isn't being added to anything. Just like that, we have our final answer, and it's already simplified. Alright, so the difference between this problem and the last problem is that this first polynomial is 3x squared minus 1, that there's no x term in here. So when that happens, and when you're first doing this stacking method, it might be helpful to put a placeholder there. That placeholder will help you keep everything organized so you don't end up with something like this at the end where you have a -15x squared and a 6x cubed and you're trying to add them. Because you can't add them, you can't combine them. Alright, so I would recommend the placeholder. Alright, we have one final example where we are taking a binomial and we're multiplying it by a trinomial. It actually doesn't matter which order we put these in. We can put the trinomial on top and the binomial on bottom, or the other way. So I've been consistent with writing the first polynomial on top, so we'll keep that going. -2x and a +7. And then I have a 3x squared, a 5x, and a -1. So 3x squared, 5x, and a -1. Everything is in its proper column, and I don't need any placeholders. -1 times 7 gives me -7. -1 times -2x gives me +2x. Then I can put a placeholder here because I'm moving to the next column. 5x times 7 gives me 35x. And 5x times -2x is going to give me -10. Don't know why I wrote a 2. -10 x squared. And then because I'm moving to the third column, I can put 2 placeholders. 3x squared times 7 is going to give me 21x squared. And 3x squared times -2x is going to give me -6x cubed. Adding these all together, -7 plus a bunch of zeros is still -7. 2x and 35x and 0 will combine to 37x. -10x squared and 21x squared will combine to make 11x squared. And then this negative 6x cubed isn't being added to anything, so we can just bring it down. Alright, so that's the stacking method. It's very reminiscent of how you multiply 2-digit, 3-digit, 4-digit, however many whole numbers. The only caveat is that you should put a placeholder to help keep yourself organized with the degree of each term. Out of the three methods that I've explained in this episode and the past two episodes, the foiling is the most popular method for my students. The box method is a second, and then only one or two students every year choose this method, but I still teach it and I still show it because it might be helpful to you, and I think it's always helpful to expand your toolkit in the way that you know how to do things. So in the next video, we're going to be looking at how to multiply special case polynomials. There's three special cases that we're going to be looking at. So whenever you're done with this video, I highly recommend you check out that one. If you found this video helpful, consider giving it a like and consider subscribing for more math lessons. If you have a question, go ahead and comment it below and I'll do my best to help you out and answer your questions. All right, thanks, and we'll see you in the next episode.